In this video, we're going to find the standard deviation of a set of data. So the standard deviation, by definition, is a measure of how much a typical value in the data set differs from the mean. So essentially what that means is we're going to be looking at, we have sets of data and we've calculated our mean, and typically it's a calculation of how far away about values are from the mean. And it's calculated not just by distance, but it also uses squares as well. So there is a symbol called sigma, you can see that right here, that is typically used to represent standard deviation. So we're going to use that here to represent it in our equation. But it's basically a measure of how far apart your data set really is. So when we calculate the standard deviation, there's a couple of steps we're going to take. First, we're going to find the mean of our data. And remember, the mean of our data can be represented by the symbol x bar. So remember that that's a symbol we can use to represent our mean. So we're going to start by taking all of our data points and calculating our mean, which is our average. So that's where we would add up all of the numbers and divide by how many numbers we have. Then from there, we're going to find the deviation, and deviation just pretty much means how far apart is everything. So you're going to take each value in your data set, so you're going to take each value, and you're going to subtract the mean from it. You can see that right here. So this is data point 1 minus the mean, data point 2 minus the mean, all the way through however many data points you have minus the mean. Once you've found each deviation, you're going to square it. So you can see that right here. You can see that we're squaring each deviation. You can see that kind of hidden in here. So we found each deviation and then we squared it. And then essentially what we do is we find the mean of those squared deviations, and this is called variance. So you can see we found the deviations. We did each x value minus the mean. We then squared them. We're then going to add them all together and divide by how many we have. So that finds the average. And once we've found that value, if we take the square root of it, that is going to find us our standard deviation value. So there are a number of steps we're going to have to go through, and it is kind of a longer process. So here on the screen, we can see that we have a set of data. And what we're going to do here is we're going to calculate the standard deviation of the ages for the ages of these people on the show. So we have a reality cooking show with 12 contestants with a couple of different ages. We're going to find the standard deviation of those ages and figure out how far apart typically these are. So here we're going to start by finding our mean, which we know is called x bar, and it's calculated by adding all of those values up. So if I add 20, 19, 25, 27, 30, and 21, if I add those all together, I end up with a total of 300. And then if I divide by the number of ages that I have, the number of people, which is 12, I find that the average age of a contestant on this show is about 25 years of age. So we start by finding our mean. We're then going to calculate all of our deviations. So I'm going to kind of do this in a step vertically here. So remember, deviation is each x value minus the mean value that I found here. So I'm going to take each value, so I have 20, 19, 25, 27, 30, 21, 29, 22, 27, 29, 20, and 31. And what I'm going to do here is I'm going to subtract the mean. That's going to find my deviation. So my mean is 25. I'm going to subtract that. So I have minus 25. So that's negative 5. This one is negative 6. This one is exactly the same, so that's 0. This one is 2. This one is 5. Then we have 4, 4, 3, 2, 4, negative 5, and 6. So that's our second step, is to find all of our deviations. Then our third step here is to square all of those deviations. So we're going to square each one of these. So we end up with 25, 36, 0, so we're squaring all of those, 4, 25, 16, 16, 9, 4, 16, 25, and 36. So we found our mean. We then found each deviation. We then square each deviation. And then our fourth step is to find the average of all of those deviations. And we find the average by adding them all up. So we're going to take each of these values and add them up together. If we add them up together, we end up with a total of 212. And then from there, we're going to divide by how many we have, which is 12. And if we divide those two numbers, we end up with approximately 17.67. And then from here, our final step is we need to square root this value in order to find our standard deviation. So we square root 17.67, and we find that our standard deviation value is approximately 4.20. So what this value essentially tells us is that the average age of a contestant on the show differs from the mean, or from that average value, by about 4.2 years. So that's our average age on the show. It's going to differ from the mean by 4.2 years. So let's go ahead and try this process one more time with a second data set. So here we can see we have a second show. It also has 12 contestants, but the 12 contestants have different ages. So we're going to find the standard deviation of this show, and then we're going to actually compare the two shows and talk about what those standard deviations are telling us. So we always start by finding our average, which is represented by X with a bar over it. So we're going to find our mean, which we find our mean by adding up together all of the ages of the people on the show. So we have all of these ages added together, which totals about 312. And then we need to divide by the 12 contestants. So we find that this show has a mean age of 26 years old. Then from here, we're going to find all of our deviations. And we find our deviations by subtracting each X value that we have, and we subtract the mean from it. So here we have all of our values. So we have 25, 20, 22, 27, 48, 32, 19, 27, 25, 22, 21, and 24. And we're going to subtract 26 from all of these. So here, this first one is -1. Then we have -6. -4, 1, 22, 6, -7, 1, -1, -4, -5, and a -2. Then from here, our third step is to square all of these deviations. So we're going to go through and square each one. So we end up with 1, 36, 16. We should be squaring them all. 1. The only one I probably don't know off the top of my head is this one. 22 squared is 484. Here we have 36. 49, 1, 1, 16, 25, and 4. So I'm going to fix that there. 25 and 4. So I found all of those values squared. Now I need to find the mean of all of these. So I'm going to take all of these values and add them together, and then divide by 12 to find my mean. So if I add all of those values together, I get a total of 670, and then I divide by the total number of contestants I have, which is 12, and that gives me approximately 55.83. So my final step here in order to find my standard deviation is to square root that value. So I square root 55.83, and when I do that, I find that my standard deviation value is approximately 7.47. So what this is telling me is that the average age of a contestant on my show differs from the mean by about 7.47 years. So the average age differs from the mean by 7.47 years on average. So finally, let's compare our two standard deviations. So our standard deviations, remember, tell us how far apart on average the different values are in the data set from the mean. So here in show A, we had a standard deviation of 4.20. And in show B, we had a standard deviation of 7.47. So with this lower standard deviation, what this tells me is that these values in this data set are closer together. And the values in this data set are further apart and they are more spread out, which if I think about it, this second data set had some larger numbers. It had larger numbers like 32 and 48. So it would make sense that the standard deviation is larger, and it's going to tell us that the average distance that an age is from the mean is about 7.47 years. So that's what these standard deviations can tell us. They can tell us how compact data is or how spread out that data will be. And in this case, show B is a lot more spread out than show A.